Hi, this is Dr. Nick from the ECG Academy, and we're going to continue this discussion of heart rate measurements. We're going to pick up where we left off with the last tracing. Now, we've already established that at a normal paper speed, the paper is running at 25 millimeters per second, and that's our time reference. Now, how do you translate the timing that we've already established as being 25 millimeters per second? How do we get beats per minute out of that? Well, again, we're going to get into mathematics. The conversion has to do with the fact that there are 60 seconds in 1 minute. And because we're dealing in beats per minute, we have to somehow put this into the equation. Now, we know that 1 second is equal to 1,000 milliseconds. So that means that 60 seconds is equal to 60,000 milliseconds in a minute. Now, that's the fudge factor, 60,000. What that means is that the rate relationship between the interval, or the time between beats from here to here, is related to rate in a calculation that rate is equal to 60,000 divided by the interval between beats. Okay? So how do you figure that out? Well, you simply count. If you know that each big box is equal to 200 milliseconds, so make it easy on yourself. Scan the ECG and look for a QRS complex that lands on a heavy line. Okay, right here. So now if you measure how many milliseconds it is from one beat to the next, and you know that a big box is 200, so let's count off 200 milliseconds, 400, 600, 800, 1,000. And now you have to kind of look a little bit carefully. This turns out to be 1,100. So now if you take 60,000 divided by 1,100, plug it into your calculator, you get about 55 beats per minute. And it's easy, right? You can do this in your head, can't you? Well, most people can't. So don't feel bad. There are other ways of figuring out heart rate, and most of it depends on how many milliseconds there are between beats. Let's kind of zoom in on one of these leads here and try to figure out what the rate is. Well, you can count backwards and you can count forwards as well. Well, here's a P wave that lands on a heavy line, and you can count backwards if you like and count milliseconds, 200, 400, 600, 800, 1,000, 1,040, and you can plug that calculation in. But there is an easier way. If you sort of like figure out let's see, if it's 200 milliseconds, 60,000 divided by 200 is equal to 300. And then if you figure on, okay, what about 400 milliseconds? Well, 400, if you take 60,000 divided by 400, and that comes out to be 150. Well, now there's a sequence of numbers, and as long as you can memorize these numbers, then it becomes very easy to count the rate. Okay, and so here are the numbers. If you start on a heavy line, the first number, if the signals are just one box apart, then the rate is actually 300 beats per minute, as I showed you in this calculation here. If the signals are 2 boxes apart, then it's 150 beats per minute. If they're 3 boxes apart, it's 100. If they're 4 boxes apart, it's 75. 5 boxes gives you 60, and 6 boxes gives you 50. If you just remember this sequence of numbers, does it make sense? Well, sure, look at that. If the beats are 5 boxes apart, 1, 2, 3, 4, 5, then it's 60 beats per minute. Well, 5 boxes is equal to 1 second, isn't it? And there are 60 seconds in a minute. So it all makes sense. If you remember, 300, 150, 100, 75, 60, 50. So what you do is you start on a heavy line, if you can, like say, for example, here. And then you count in one direction or another, looking for the next similar signals. So 300, 150, 100, 75, 60, and this would be 50. Well, now you're going to have to kind of fudge it a little bit. If this is 60 and this is 50, then your heart rate here must be something just below 60, and you'd probably be okay to call it 58 beats per minute. So that's a quick and easy way to figure out the heart rate. Okay, so we're going to go back to this tracing, this whole 12 lead on that 18-year-old person. And we're going to get a sense of how do you measure rate on a 12 lead. Well, as I said, you kind of have to scan around and look for a QRS complex that lands on a heavy line. And this was the one that we used before. So if you count off, we can say 300, 150, 100, 75, 60, 50. So if this is 60 and this is 50, you have to kind of call it 55 or so. And that's what we came up with when we did that mathematical calculation. Okay, so it kind of makes sense to do this. Well, let's try it again. Here's one that lands on a heavy line, so let's count it. 300, 150, 100, 75, 60. Wait a minute. Wait, that's not the same. If this is 75 and this is 60, then we're talking a rate of like maybe 68 beats per minute, but that's not the same as this one. So it turns out that there is such a thing known as sinus arrhythmia. Sinus arrhythmia is a normal finding, and we're going to discuss it when we talk about sinus node function. But sinus arrhythmia occurs in normal people, especially 18-year-olds, and it has a lot to do with the nervous system's effect on the heart rate. And even with just respiration, the heart rate will vary from one beat to the next. So it becomes a little bit difficult, but I want to introduce you to the electrocardiographer's best friend, and that is calipers. Yes, indeed. Calipers are a way of trying to get a sense of whether we have a regular rhythm or an irregular rhythm, and it also allows us to make measurements that we otherwise would have difficulty making. For example, when things don't land exactly on a heavy line. So you take your caliper, and I'm just putting it on this point here. And then what I'm going to have to do is electronically kind of like resize it so that the other point lands on this other QRS complex, okay? And so then when you move the calipers from one beat to the next, you can get a sense of whether the interval is the same. This is almost the same, but clearly this interval is a little bit shorter. The R to R interval from the one QRS to another QRS is shorter than what we saw in the first couple of beats, and this is much longer than we saw in the first couple of beats. So yes, indeed, there is a bit of a challenge in measuring rate. You have to kind of look for an average heartbeat and measure it. Now I'm going to show you a way around that a little bit later in this video, but first I want you to get used to using these calipers. Now the cool thing about calipers is it lets you measure things that don't land exactly on a heavy line, and I'll show you how. Well, let's go back to this first interval here, and we're going to put the point of the caliper on the first beat, and the second one, I guess maybe I could probably resize that a little bit better so that it lands on this second beat, okay? So now that's showing us exactly how long the interval is. Well, now, how do we measure that without having to count little tiny boxes and get into milliseconds and do crazy stuff like that? Well, once you've established the interval here, you simply pick up your caliper off the page and you lay it down on another part of the paper such that the left-hand point is right on a heavy line. You can see that I've placed it on this heavy line, and now you can see what the interval is. If you want to count off in milliseconds, it's 200, 400, 600, 800, 1,000, probably 1,040, maybe 1,060 if you look carefully. We're going to zoom in on things in the next video, so you'll be able to make fine measurements of PR intervals and so forth. But for the time being, you can make gross measurements without having to count little tiny boxes. In terms of heart rate, we're talking, start with this one and count off the numbers, as I said before, 300, 150, 100, 75, 60, and you see it's a little bit less than 60, but it's nowhere near 50. So again, we have about 58 beats per minute, abbreviated BPM. Okay, so this first beat is 58 beats per minute, but there's a normal degree of sinus arrhythmia such that sometimes it's at 68 and sometimes it's down to 55 and so on. So that is your basic approach to determining heart rate. The key here is that you really have to look at the whole entire tracing. I always tell people when you're first looking at an ECG, you really have to look at the whole forest. Don't concentrate on the trees. Don't zoom in and look, oh, look at that. That fifth beat over there has a little funny squiggle. I wonder what that is. Well, before you get into those tiny details, you kind of have to scan the whole ECG all the way across and get a sense. Is it regular? Is it irregular? Are all the beats kind of about the same distance apart? In which case you can sort of like use any one you like and you'll still kind of be in the ballpark. Or is it very irregular? And I'm going to show you an ECG that's very irregular next. Now here's an example of an ECG where the rhythm is irregular. In fact, this is an abnormal rhythm. It's known as atrial fibrillation. You may have heard about that. It's due to a rapid electrical disturbance in the top chambers of the heart, so the atria are beating 1,000,000 miles an hour, but the AV node winds up passing a rather random signal down to the ventricles, and so the heartbeat is irregular. And you can see some of these intervals are actually very short, and other intervals are very long. And determining heart rate is a little tricky because depending upon which interval you measure, you could get vastly different heart rates. So calipers aren't terribly useful under these circumstances, but I'm going to show you something that is useful. Well, one thing you can do is just run a strip that's a whole minute long and count the number of R to R intervals in a whole minute. And that would give you the number of beats per minute. Well, that kind of would be a bit of a waste of paper, and it would also mean you'd have to sit there with the patient for that long. So that's not a practical solution. But what if you ran the ECG for 30 seconds, counted the number of heartbeats, and then just multiplied by 2? Well, that would give you the number of beats in a minute, right? Well, take that idea a little bit further. What if you only ran it for 10 seconds? Then you'd have to just multiply by 6, and then you would get the beats per minute. Well, I got an even better idea. Look down at the bottom of this tracing, and you'll find pretty much on every single printed ECG these little doodads. These little marks here are known as 3-second marks, and they're spaced, surprisingly, 3 seconds apart. So if you measure the number of R to R intervals between two of these marks, that would give you 6 seconds. And then you can multiply that by 10, and that would give you the number of beats per minute. So let's figure this out. Try to find a QRS that's more or less close to one of these 3-second marks. So we'll pick this one. Now you're going to measure, this is 3 seconds, and this is 6 seconds. How many R to R intervals are there in 6 seconds? Well, this R to R is 1, and this one is 2, and this one is 3, 4, 5, and now you'd have to say like 5 and maybe a half, or maybe 4/10. So that gives you a rate of 54 beats per minute. Now, of course, if you measure something a bit different, so if you go from this one to this one, you may get a different number. So this would be 1, 2, 3, 4, a little bit more. You might get 42. But this is a challenging ECG because the rate is so tremendously variable. But it gives you a tool. It gives you a way of measuring grossly irregular heart rates using these 3-second marks. Well, this is one of those tips you'll only get here at the ECG Academy. And that concludes my discussion of heart rate measurements. In the next video, we're going to be talking about measuring intervals like PR, QRS, QT, and so forth. This is Dr. Nick for the ECG Academy. Thanks for watching.